Hello guys, welcome back to VC Tech. Almost every network you use today at home, in an office, or even in an ISP, it relies on one powerful technology called Port Address Translation, or PAT. In this video, I'll break down what PAT is, why it's so important, and how we use it in a modern network, and why it is the most common form of NAT in the world today. By the end of this video, PAT will finally make sense, even if NAT always confused you before. Ever wonder how hundreds of devices just share one public IP address? The answer is Port Address Translation. In this video, I will explain exactly how it works and why we can't live without it. So with that being said, what is PAT, or Port Address Translation? Port Address Translation, also called NAT Overload, allows multiple private IP addresses to share one public IP. It uses port numbers to track individual sessions. So we have 100 IP, or we have 100 devices in the network, and they all use the same public IP to access the internet. However, there is a specific port number that differentiates which device is connecting, or which device is using this traffic and which device is using that traffic. And Port Address Translation is the most widely used NAT technique today. So why is PAT important? Public IPv4 addresses are limited. PAT conserves those IP addresses by using a single public IP to enable internet access for an entire network. So imagine if we have a network of over 100 devices in a network. They all use the same public IP address. However, the port number is always going to be different. I'm going to show you that when we get to the configuration phase. It is also very critical for modern network. How PAT is used today. PAT is used in homes and enterprise router. It supports thousands of simultaneous connections. It tracks traffic using source port number, and it is common in ISP edge network. The benefits of Port Address Translation includes it saves IPv4 address space with its cost-efficient network design. It also hides internal IP addresses, and it is scalable and easy to deploy. So with that being said, let's head over to our configuration phase where we get to configure Port Address Translation on a router. So we have 3 host devices for this tutorial, 1 router, and this is going to be serving as the internet that this host devices will be trying to get to. I've already assigned IP address to those devices. Let me assign IP address to this device, and we are going to try to ping. Then we'll see what IP address it is using to get to this device over here. So 203.0.10. This should be taking, this should take .5. So we want to copy this IP address and just paste it here, and with the default gateway of 1, so the default gateway is 203.0.10.1. Alright, so now we've done that, let's head over to the host devices and try to ping that device. Then we check our NAT translation and see what IP is using to get to that destination, if we are going to get any record. So ping 203.0.10.5. So we are able to ping 203.0.10.5. So let's check. Let's do this. So let's check our NAT translation. Do show IP NAT translation. As you can see, we don't have any NAT translation on our router because we've not configured any. Now let's configure PAT on the router to enable this host device to use one public IP address to access the internet. And we are also going to check the unique port number for every host device that uses the same public IP address. So let's head over and start the configuration. What we are going to do now is to create an ACL to permit this inside network. We are going to create a standard ACL, so IP access list, and we want to specify that this is standard with number 10. We also want to permit the network, which is 192.168.1.0 with a wildcard bit of 0.0.0.0.255. So by doing this, we've created an ACL permitting the inside network. Our second configuration for this tutorial is going to be to configure NAT overload on the router, enabling these host devices to use a single public IP address whenever they want to make use of the internet. So we can do that by saying IP NAT, since we've already created our access list, which we have here. Let's go and create our NAT overload on the router. So we say IP NAT inside, and we also want to specify the source and also list out the access list that we created, the access list number we created, which is 10. So we say 10. And for this, previously when we discussed dynamic NAT, we used pool of IP addresses. However, for paths or NAT overload, we use the interface because it is going to be specifying an interface that the devices in the local area network are going to be using whenever they want to leave the local area network and access the internet. So we're going to say interface, and that interface is this outgoing interface of the local area network, this interface over here. So we are going to be saying the gigabits port of interface gig 0/1. So gig 0/1. And lastly, we want to specify overload, because as we call it, NAT overload. So we want to specify overload over here. After doing this, we are not completely done, but we've done most of the configuration. We've already created our ACL permitting the inside network as we have here. We've also created our IP NAT telling the router that whenever the host devices in the local area network wants to access the internet, they should use the public IP of interface gig 0/1 as we have on this line. So it should be using interface gig 0/1. Now let's try to ping and see if we are going to get a NAT translation on the router. So let's ping 203.0.10.5. We can ping the server or we can ping the internet. Now let's try to do a do show IP NAT translation and see what we get. Of course, we got nothing because we've not configured the last part of this tutorial. However, if we check the statistics, we also did not get anything from there because there is one piece of configuration that we've not done, if you can remember from the previous tutorial we had. So we've not done interface gig 0/0 to be the inside network as we have here. It is the inside network, so we want to say interface gig 0/0 IP NAT inside. And we also want to do the same for the outside network, interface gig 0/1 IP NAT outside. By doing this, we've activated the IP NAT that we created on the router, telling the router that the inside devices should use interface gig 0/1 public IP address to access the internet. So previously when we tried to ping and check our NAT translation, we got nothing. Let's try to do that one more time and see what's going to happen this time. So let's go and check our do show IP NAT translation. As you can see, we got a translation because we've activated our IP NAT inside and also IP NAT outside. Now for the inside global, this host device right here, 192.168.1.2, is using the public IP address of 203.0.10.1 with a port number of 5. Now let's also go and check. Let's also ping from these other devices and see what's going to happen. So ping from this device that has the IP address of .3. And let's also go and check as the name goes, NAT Overload. If you look closely, 192.168.1.3 has the same inside global address as 192.168.1.2. As you can see over here, it has the same public address of 203.0.10.1, and 192.168.1.3 has the same public IP address of 203.0.10.1 with a port number. This is the number that differentiates which device is carrying out which traffic in the network. Let's also ping with the last device and see what's going to happen. So let's ping 203.0.10.5. We also gain connectivity. Now let's go and check our NAT translation. See, so 192.168.1.4 is also using the same inside global or public IP address as the rest of the other host devices in the network. As we have 192.168.1.2, it has the same IP address as 203.0.10.1, and we also have this private IP address of 192.168.1.3 that has the same public IP address as 192.168.1.2 and 192.168.1.4. Now let's try to ping. Let's make use of all the devices. Let's try to ping with all the devices and see the translation that we are going to be getting. Alright, so let's go and do that here and see what we have. And as you can see, guys, we have the IP address. Take note of the IP address, it's very important. So we have an IP address of 192.168.1.3, and we also have another IP address of 192.168.1.4, and we have the last IP address of 192.168.1.2. There's something unique about the private IP address with their public IP address. Now, as you can see, they all have the same public IP address as 203.0.10.1, but the port numbers are different because this is what the router used to track which device is carrying out which traffic on the network. Guys, if this video helped you understand how private IP on our devices change to public IP when we want to access the internet, why not smash the like button and subscribe to this channel, because on the next video we are going to be talking about something even more interesting. Thank you guys for watching this video, and I hope to see you in the next.